Assalamu alaikum.
With? Okay.
Assalamu alaikum. Myself Shiraz Islam, working as research associate in Department of Electrical Engineering, Qatar University. Here I am going to explain about my setup, what we are doing here. This is the practical setup of my hardware. So I will explain what is happening here. In this diagram, actually it is the converter module where we are just producing a 15 level output with the help of this converter module, and this module is a multi-level converter. It is a multi-level inverter. At the input of this we require two sources, and these two sources are the solar PV. Now at the input of this source solar PV, this solar PV output is coming at this here, and we are connecting the output of solar PV to the MPPT. This is a MPPT controller. So it requires two sources. Source 1 is connected to this MPPT, and second source is connected to the charge controller. It is not the MPPT, it is the charge controller. It is controlling the charge of the battery, which is connected across its output. Similarly, module 1 has a battery which is connected at the output of the solar inverter. Now the battery capacity across this first MPPT controller is around 12 volt, but it's not fully charged. We can observe from the screen it is charged to the value of 10.5, and the ampere hour capacity of each battery is 6 ampere hour. You can see down, 3 batteries are connected in parallel. The capacity of each battery is 6 ampere hour. Now the total capacity of the battery bank will be 18 ampere hour. Now 18 ampere hour 12 volt battery is connected to the MPPT controller, which is shown here. Now similarly, on the white unit is the charge controller, and you can see from the below the table, 3 batteries are connected in series. The battery voltage of each battery is 12 volt. Now it is coming out to be 36 volt. Since this is charge controller, the maximum voltage that we can set on this unit is 30 volt. So we cannot increase the voltage of the bank beyond 30 volt. As soon as it goes out beyond the value of 30 volt, I mean the solar converter, solar PV tries to charge this battery more than the value of 30 volt, it will come to the down 30 volt. So it is I'm controlling the battery charge in such a way, as soon as the battery voltage goes up, it tries to dissipate that extra charge, and it tries to bring the voltage nominal up to the nominal value of 30 volt. That's why this operation is reflected here. See, now I am getting a 15 level voltage, but this waveform is not constant, it is dancing. Why? Because dancing, this is because of the charge controller action. This is happening there. Now at the input of these two sources, I mean solar PV1 and solar PV2, we have connected two big capacitors just to maintain the constant value of the source output voltage. I mean solar PV voltage, source 1 and source 2. We have connected these two sources here. With the help of these two sources, we are generating a 15 level output voltage here. Now we can see that for 15 level converter output voltage, I mean inverter output voltage, we are getting here. The orange one is the voltage waveform, and the green one is the current waveform. Now we can see the load is connected here. I have connected the load of 450 ohm here. Now I am getting these waveforms. Similarly, we can observe the operation for the other loads, for the other values of the resistive load, and for the other values of the resistive and inductive load. Now this is my power quality analyzer. It is showing how much distortion we are getting in the waveform, how much current is flowing, what is the power factor of the source, and what is the frequency of the output voltage we have generated here. This information we can get from the power quality analyzer. This is all about my setup. And now we are using Xilinx board for programming our circuit. We are generating the gate pulses which are required for firing the various modules. We are generating these pulses with the help of Xilinx. Now this Xilinx is supplying these pulses to the gate drivers. Now we can see these gate drivers are here. Now it requires 5 modules. Now these 5 gate drivers are supplying gate pulses to various modules. Now on the basis of that firing pulse generation, we are getting a 15 level output, which can be validated with the help of waveform which is visible on this Yokogawa oscilloscope. This is all about my setup. Thank you very much.